Welcome everybody for another round of peer review club where we take in a small PR from Bitcoin Core and then basically try to parse it from our side and hopefully learn something along the way. So today we are taking PR number 28336, which is a very short PR about some sanity checking of public keys. Right, so this PR basically modifies some helper functions, which does some sanity checking. Previously, these functions were all over the place, and now the stack has consolidated those functions, and now it's nicely used in one single function. All the logic checking for public key is correct or not, and then this function is used in other places. So usual stuffs. If you have any questions, feel free to raise your hand or post it in the comments. We will have an eye on that. And the goal of this is like the participant should be able to submit a helpful review comment on the PR at the end. So with that, let's get started. Strat, all yours.
Okay, so this is the PR. It's basically as Raj described. We're going to pass the legacy public keys, and like it's already being done, but we're just going to make it systematic and consolidate all of them nicely, cleanly in the code base. So let's just read the description. Passing legacy public keys can fail for 3 reasons in this order. The public key is not in hex. The public key has an invalid length, not 33 or 65 bytes for compressed, uncompressed respectively. The public key is cryptographically invalid, that is, it's not on the curve. Many RPCs currently perform these checks manually with different error messages, even though we already have a HexToPubKey helper. This PR puts all 3 checks in this helper. The length check was done on the call sides before. It adds a specific error message for each case and consequently uses it all for RPCs that parse legacy public keys. This leads to deduplicated code and more consistent, detailed error messages for the user. And these are the affected RPC calls where this refactoring has been done. And note that the error code -5, which is RPC invalid addressor key, doesn't change in any of the cases. So the changes are not breaking the RPC API compatibility. Only the messages are more specific. And then there's a last commit which will add test coverage for cryptographically invalid public key case, which was an exercise before. So basically, I see 3 concepts here, which you have to look into. One is, what is a public key? What are the types, compressed, uncompressed? And then, yeah, we'll just see how it's used in the code. Does it sound good?
Right, makes sense. So to the spirit of review clubs are meant to be interactive, and usually there are questions where the participants are supposed to answer the question. So how about we start with the basic question of what is a public key, and anybody can take that up. Let's try.
Yes.
Yes, Clady.
Yeah, so public keys are basically the keys which are derived from the private keys. The main goal of the public key is to share the addresses without basically compromising with the privacy.
Makes sense.
Public keys are used in various places, for example, to sign transactions, etc.
Right. What
Not
does
to
a
sign
public key
transactions,
usually signify? In many cases, like in banking to other infrastructure, you have like public keys available. What does it usually signify? Like when somebody gives you a public key, what does it basically mean? Yeah, Fazal raised his hand. So Fazal, go ahead.
Public key basically proves that you know a secret, and you prove that you know that secret without revealing that secret.
Isn't that digital signature?
The digital signature,
Yeah,
sorry,
I mean
that's a
what you I get what you mean. Yeah.
Yeah.
Or like we can say that public key is one part of the
I mean, the
public-private key pair.
Yeah,
With
yeah.
the digital signature, what it proves is that the public key is also deduced from that private key without revealing the private key.
Mm-hmm. Yep. Yep. In a way. Okay. Setu?
Yeah, so public keys are basically identifier of people in the system.
Yes. Basically,
Yeah,
that's what I was looking for. It's an identifier of. It's kind of like an ID in a pseudonymous system where you don't have a central authority assigning people IDs. Public keys become the ID in that system, and yep, and eventually you can do a lot with that public key. You can verify a digital signature if you sign messages with the corresponding private key of that public key, and many other things. Mostly for like digital signatures and verifications. Then you can do some other fancy things like Diffie-Hellman key exchange, where two people showing off their public keys can derive another public key where they both can decrypt and encrypt messages within using that key pair, the new derived key pair. So all of those stuffs. So yep, great answers everybody. And so on the next part, another easy one is what is a compressed and uncompressed public key, why there are two types, and why would we want to have uncompressed public keys? Anyone? Faisal, yes. Faisal, you are muted.
Oops, sorry. The public key is a point on the elliptic curve which has an x coordinate and the y coordinate. So either you can share both the coordinates, which is the uncompressed public key, or you can just share the x coordinate and indicate whether the y coordinate is odd or even, because the ECTSA curve is symmetric along the y-axis, x-axis, sorry. So the y coordinate can have two possible values. So you just indicate whether it's odd or even, and using that, it can be deduced what the value of the y coordinate is. So initially the keys were only uncompressed, but later on, for data economization reasons, we also came up with the concept of compressed keys.
Awesome. That's as elaborate as an answer for this question can get. Thanks a lot. And so okay, Strat, let's move forward.
Yeah, perfect answer. Yeah, so yeah. We also forgot to mention that mathematically, public key is a point on an elliptic curve here.
Mm-hmm.
Yeah. Yeah, okay. So, yeah. Wait, what is the third thing I wanted to check?
I mean, like conceptually, I guess like what this PR is trying to do makes sense. So concept ACK on that. And then what we can do is like look at the change set and try to see where are the changes are affecting in the code.
Yeah. Yeah, so maybe we should look first into this helper, the RPC check and throw specific public key passing errors in HexToPubKey. So
I mean, core PRs are amazing like places to learn how to write like elaborate PRs with these PR messages and stuffs. So each of the commits are segregated into logical chunks, and then the commit message includes a detailed description of that specific commit. So this is like amazing making PR best practices.
yeah, it's so good.
Yep.
Yeah, so yeah, so the HexToPubKey helper function, you can see it's in RPC util.cpp.
Mm-hmm.
And this is the function.
Right.
So like you can see the change sets, like before it was just checking if it's not hex. Like this is the function, it takes as the input the hex string, hex in. So if it's not a hex string, you just throw this RPC invalid address or key, this error, and it just displays invalid public key.
Right.
And this is interesting. We should maybe go look into this function.
Makes sense. Yeah, so Clady asked, is this the whole commit message? Yep, that is the whole commit message, and that message like describes what that specific commit is trying to do. So one way of like reviewing is like read the commit message, understand what it is trying to do, then read the code and validate that the code is doing exactly what the commit message said that it should be doing.
Yeah. So, like you can see that some stuff have been added, but after this thing, like what it's basically doing is it's instantiating a public key instance using the hex string. So there's a internal utility function which is used
Right.
in src util str encodings. We'll trust that it does what it does. And this is interesting, like you instantiate the C public key instance using this construct. And this is the name of the public key.
Right.
Strat, I have a question in here. So we are comparing the two repos, right? You were comparing both the repos, the change that is being suggested and the original one.
I haven't started comparing it. I just want to understand this, how this constructor works, like how it's actually, like how the hex string actually becomes a C public key object.
Yeah, so what we just saw before in the web, like in the browser, is like a change set. This is called a change set, and the change set is like what you see on the left hand side is what was original. What you see on the right hand side is what is new. So the red lines is basically denoting like what got deleted from the left, and the green lines is denoting what got added on the new one in the right. So, and on the code in the editor, what Strat was showing, that's the current version of the code. So that's what you see when you get the check out the PR basically.
Yeah, it's the latest version of the code.
Yeah.
So if you go into the CPubKey thing, where is the constructor? So yeah, constructor public key from the byte vector. So what does parse hex return? Yeah, it returns a byte vector. So that means where did it go? Yeah, so you construct a public key from this byte vector. You just passed in this byte vector, and it calls this function set. And if you go inside here, it's you're initializing a public key using
begin and end iterator of the byte data. So it's basically taking the byte data and constructing a public key, and the public key is basically a byte data, and it's a series of bytes which denotes a public key, I guess.
Yeah. So they're basically instantiating what the length should be and what VCH should be. So if we scroll up, we would probably see like VCH is where you store the bytes.
Yeah.
The actual and
VCH usually denotes vector of characters, right? That name VCH. I'm guessing. Could be something
probably.
else.
I used to think of it as variable characters in my mind, but I think vector of characters makes more sense.
Okay. Yeah, I think like, yeah, I have seen it in many places in code where they put like a byte array as VCH.
Yeah.
Okay, Clady wanted to ask.
The parameter that we are putting in the function, that array of bytes. So what does that array of bytes signifies? Can you please explain?
I didn't get the question.
So array of byte is like you got
the
a hex string, right?
Yeah.
And that's a 33 byte hex string. You transform that hex string into a series of byte values, right? And
Yeah.
that's the array of the bytes.
Yes.
My question originally is like, what does it signify?
It signifies the public key. Like the public key data as an array of a byte, you get 33 bytes of data.
That is what we get. I'm asking like the parameter that we are putting. It is
Oh, like the p begin and p
P
end.
Yes.
Right. So p begin and p end basically is a pointer to where the character starts and where the character ends. And then it's just doing mem copy. And mem copy is like you copy from memory from that character to that character. Whatever is the data, you just copy and put it in a variable. That variable is VCH.
Okay.
Right. So it basically calculates the length. That was an interesting function. It calculates the length from p end, p start to p end. Where did it go? Yeah, the set. So from p begin, p end, between that it calculates the length, and then it calls a mem copy, which is like unsigned character pointer point starting at p begin up till length of length, and copy that data and put that into VCH, which is a vector of characters, like vector of bytes.
Makes sense. So now we have the vector of bytes, and like we have CPubKey, the object with all the stuff filled in, and then they check if it's fully valid.
Right.
So if we go into that function, oh yeah, this is where they call the internal secp APIs. Like
Right.
this is the code, and it's called, like, there's more C++ code here. What is this valid? Oh. Check syntactic errors when setting a public key or deserializing fails. The size is set to 0. Thus, by checking size, one can observe whether set or deserialization has failed. Interesting. So this is like just to check some serialization to make sure that all of that worked good. And then this is where they call the internal secp APIs. Like we have, yeah, this was something I wanted to share. This was some like this will actually call an internal libsecp API. So it's actually in src secp256k1 include this. src secp256k1, it's like maintained as a separate subtree in, it's like an upstream repository. So if you like check at all the commits here, see, like they are all squashed. So we have something called secp256k1. And in this repository, all the pull requests and like changes, everything is made, and they all get merged or whatever. And then, so before every release, or like if there is something new we want from the secp in Bitcoin Core, we will do these kind of subtree merging, squashing commits to update this repository, this secp256k1, like the whole thing, to whatever is there inside libsecp.
Right.
So if you look,
so basically this secp is like a externally maintained library, right? And it basically takes periodically changes. Whatever happening in secp is periodically is pulling in via a squash commit into Bitcoin Core.
Yeah. So like if you like search for this commit, you'll probably see a lot of them.
Mm-hmm. Makes sense.
Like you see so many of them, like they were all updates, and they're all like all these commit IDs from secp, you get it here.
Makes sense.
Yes. So it's maintained as a separate subtree. And yeah, I also wanted to share that, like, if you look in the developer notes, you'll see that these are the current subtrees which we maintain, like which Bitcoin Core depends on. Like one of them is secp. Then there are also other stuff like level DB, something for checksum, something for AES, something for mini sketch.
Mm-hmm.
And yeah, all these are maintained by Core, but some things are not.
Like level DB is not maintained by core, right? Level DB is like a separate project on its own.
Yeah, but apparently we are using a subtree which is maintained by core, which depends upon the level DB subtree.
Okay. Okay.
And it's not that active, like it's 2 years ago. Not much changes.
So Kevin asked, this repo is for the public key elliptic curve cryptography logic for SecP. Yeah, SecP is like ACCP 256K1 is like all the logic related to the elliptic curve of ACCP 256K1. That means like public key, private key, digital signatures and stuffs.
Yeah. Yeah, exactly. And recently I think they added this.
No, that specific elliptic curve. That's ACCP 256K1 and not other curves.
Yeah, just SecP. They had like recently there was a pull request where they like talked about the scope of libsecp. I just wanted to show that. Can't find it right now.
Okay.
I thought it was more. I don't know. Can't find it. We'll check it later. So yeah, so you can see that in pubkey.cpp, this is like where we interact with the secp APIs.
Mm-hmm.
So yeah, so this is fully valid basically calls the libsecp version. And if you go there, like they have like pretty good documentation about how the parsing is done.
Right.
This function supports parsing compressed 33 bytes, that is 0x02 or 0x03, uncompressed 65 bytes, or hybrid format public keys. Have you heard of hybrid?
Nope,
public
I
key?
haven't heard of hybrid public key. What it is?
The monstrosity.
Sounds like some complex thing that nobody wants to talk about.
Yeah. Miniscript very recently removed support for hybrid public key. Like you'll understand why when you read it. It's something from the OpenSSL era.
Okay.
They used to have for something called this hybrid public key, and since libsecp depended a lot on that library, they also like support this, something like that. But
So
this is
it's just 0607 and 32 byte X? Oh,
Yeah, so
then
it's
32 byte Y also.
Yeah, so normally like if we have uncompressed format, like it's 0x04 followed by 32 byte X and 32 byte Y coordinate.
Right.
We don't need the information whether it's even or whether it's odd. Like
Right.
we want to know if the Y coordinate is even so that we can reach this place. Like we know the X coordinate and the Y coordinate, right?
Right.
Like if it's an even Y, we can find the appropriate Y coordinate. If
Right.
it's an odd Y, we can find the appropriate Y
Right.
coordinate. Hybrid format, what it does is it's even like it has the X coordinate, it has the Y coordinate, and
it marks whether Y is even or odd.
Yeah.
Oh, okay. Like
So-
I'm just curious, why would someone need that to mark it separately? It's obvious from the data, right?
It's obvious from the data, but apparently from what I understand, it was something like OpenSSL had it, and so when we wrote secp library
to be compatible with OpenSSL, they just kept that.
Yeah, and that happened.
Mm-hmm.
We don't use it now. Like Miniscript recently had a PR merge to totally remove these kind of hybrid public keys. I think like it still support this. I'm not really sure.
Makes sense. Yeah. Yeah, I mean, that's what this explain. Handling them is trivial. If you see a public key starting with 06 or 07, use it as if it was a 04 instead. Yeah, makes sense. It's kind of like a old historical standard that got like left with the code.
Yeah, this is in 2012.
Okay, makes sense. I wonder like why it's still there in ACCP. I'm pretty sure nobody uses that.
Yeah.
Okay, cool. And then I guess this API also calculates whether the public key is on the curve.
If the public key was fully valid, yes. It calculates. This is where the logic happens, whether the public key is really on the curve or not.
Right. Shaksham asked, can this project run on Fedora Linux? Do you mean Bitcoin Core? If yes, then yeah, like there is a doc in Bitcoin Core developer documentation inside the repo. If you go in the doc folder, there is build doc, and inside that you will find Linux Fedora build instructions along with many other build instruction, Arch and many things. You can build it in pretty much any architecture. Cool.
Yeah. This is the code inside, but we're not going to go into it because that's getting
Right.
out of.
Yeah. Let's get back to our pubkey.cpp, like things we are familiar with.
Yeah. So where were we? Like, yeah, we were checking
Yeah.
out what fully valid was, and we went into the secti thing.
Yeah.
So if you look at the chain set, like what he has done is, if it's not a hex, instead of saying it's invalid public key, like you're giving a proper description.
Saying like
The
what went wrong, like it must be a hex string, so it wasn't a hex string. So now like the error messages are more elaborate depending on which error it caused. It's more elaborate, so then it's doing the length check. So if it's not proper length, then it's a wrong public key. So it's throwing like the public key must have a length of either 33 or 65 bytes. We are still supporting 65 bytes public key in Bitcoin Core.
Yes.
Like you can create an address with a 65 byte public key.
I guess so. Like,
Okay.
uncompressed keys are supported, from what I understand.
Right.
I'm
Okay.
not really sure.
Yeah, maybe there could be some standardness rule gate where like that get filtered out or something. I'm guessing like might not be the case. Like you can still create a valid transaction with 65 byte public keys.
Yeah. Now we are advocating for X only public keys, right? After Taproot, just 32 bytes. Right?
Yeah, like makes sense. Like the X only public key. But are we really advocating for X only public key? I heard like it's a mess. It's a mess.
But
Yeah.
what do you mean? It's a mess? Like,
I'm not exactly sure why it's a mess, but I think like there has been a lot of compatibility issues while trying to maintain the parity bit of the public keys all the time. So like a lot of people, there was a meme going on in the Twitter space some months or years ago, maybe like X only public keys was a mistake. And the amount of code complexity it generated to save 1 byte, people say that it wasn't worth it. But I'm not exactly sure what was the reason. I guess the reason was like previously you could use like odd public keys, and all the codes that were handling odd public keys now have to be rewritten to only use even public keys to interact with Taproot and stuffs.
interesting.
Yeah. So, but we kind of like stuck with X only public keys now. So I guess we have to deal with it.
Uh-huh. Yeah. I don't really know.
Yeah.
I should.
I heard some discussions. There were some discussions. I'll scour up some links and try to post it in the Discord. There were some discussions about like some complexity emerged. I think it was Sipa who was also talking about it. So he might have some more context.
Stack Exchange. Okay, we'll check it later.
Yeah.
Yeah. Okay, so 33 bytes, 65 bytes. And yeah, then if it's not fully valid, you actually tell the public key must be cryptographically valid.
Makes sense. So these are all the 3 checks we can do on a public key, nothing more?
Nothing more.
Hmm.
What else is left?
Nothing comes to my mind. Okay, so previously like HexToPubKey was just using some checks. Now we have some more elaborate checks. Yeah, Setu?
Just a operational question. So we do have both the like version of code, the changed one and the older one in this commit history as well. So why do we keep going back to like our virtual basic and see the previous version of code there and not have it like look it here?
You
So,
mean
like,
in
what-
code editor?
Yeah.
Yeah, so in the code editor, we are looking at the code so we can jump into definitions and like function definitions. We cannot jump into function definitions here. It's just a text.
Oh,
And in code
Okay.
editor, we actually want to look into different functions and see what they're doing.
I want to know is hexes. So if I click here, nothing happens. But if I click here, wherever it is, I'll go
Yeah.
inside it. So I'll get more context.
got it. Got it. Makes sense.
You can like check the change set, like the way it's showing in the browser inside your code extension also, like code editor. And that will also, yeah, basically something like this. That will also give you a change set. And that's a better way of like looking at what changed than looking into the GitHub history.
Like this is in my code editor, I can get the change sets.
Yeah.
Yeah. Anyway.
Okay, cool.
And as always, if we ever add all these messages, we also need to add test coverage for it.
Cool. So Clady had some question about the most basic question you can throw about RPC. What is a RPC? So after this, we are going to look at some RPC code, I guess, like where it got changed in which RPC ones. So before we jump on that, anybody want to take up the question, what is an RPC?
The thing is, Raj, I know it, I understand it, but it doesn't just make sense to me right now. So like, especially in the context of Bitcoin, what is like, how does it work? If you can, if anyone can explain that part, I would be really glad.
Okay, anyone?
I know it, but I don't know it.
Okay, makes sense. Anyone willing to take a shot? How does Bitcoin Core RPC works? Shreyan, when Dev talks
It's
about
like we
RPC, it
want to-
feels okay. Yeah, Setu, go ahead.
My understanding is like there's no API endpoint exposed. You want to talk to your own node, and so you do. So that's how you talk to your own node. If it were someone else's database, you would have used an API maybe. But since it's your own, like you are running Bitcoin Core on your own computer, you use RPC to
You can
query
use someone
that.
else's node also if they give you the RPC credentials, like the username and password. So yeah, the RPC is called remote procedural calls, and it basically is generic computer science thing. It's a generic way of throwing an instruction and getting a reply from a service or a software or a daemon or a web server or whatever, right? So
But that's the API is also, right?
that's an API also, right? So RPC is also an API. So you can, so if you do Bitcoin CLI is the RPC app to talk to Bitcoin Core. So what it basically does is like when Bitcoin Core starts, it starts an RPC server. An RPC server is nothing more than an HTTPS server. An HTTP server, I think, because it's working on local, it does not have HTTPS. So it's an HTTP server. So the Bitcoin CLI throws HTTP requests to Bitcoin Core, and Bitcoin Core gives HTTP response back to Bitcoin CLI. Bitcoin CLI takes that response and put that into your terminal. So Bitcoin RPC is a way to talk to your Bitcoin core node when it's running, right? So there is a node that is running, which is like a black box, which is doing its thing, managing database, connecting to peers, validating blocks, all these things. But you want to say like, hey, what's the current block height? You want to ask this question to Bitcoin core node, right? The way to do that is like you will go to Bitcoin CLI get blockchain info. So what get blockchain info does underneath is like it creates an HTTP request. It sends that request to the HTTP port of Bitcoin core. So the RPC port for mainnet is 8332, and it sends that HTTP request to that port. Bitcoin core processes that request, sends a response, and then you get the response, right? So that's basically the concept of RPC.
Like we can assume, for example, we have many microservices running, for example, Bitcoin CLI, Bitcoin daemon, and other things, and RPC is basically used to abstract out anything and get response from any other process. Like, can we think of it like that?
Yeah. Like whenever you have a daemon or a service or a server running, you have RPC kind of situation, right? So Bitcoin CLI is an app. It's not a service. It's not a daemon. It's an app which like executes on single commands. Bitcoin node, the Bitcoin T, is a daemon or a software or a service or a server which basically spawns and runs and does its thing, right? You cannot like directly send command to it. So use RPC to do the command. So Strat, can you like open up Bitcoin CLI any command help? There is a way of like sending RPC commands to Bitcoin node using that thing. What is that thing called? Forgot.
Is it curl?
Curl. Yeah.
Raj,
Yeah.
if
Right. So you can curl into Bitcoin core, right? So just like you can curl into any web server, send it an HTTP request and it will give you an HTTP response. You can curl into Bitcoin core node, send it an HTTP request and it will give you an HTTP response. And that's remote procedural call.
Is it that other thing written in RPC help? Like I see.
Yeah. It's written in RPC help. So all the RPC help command has a corresponding curl function, like a curl call that you can make with like you can craft the HTTP request by yourself. It's kind of like a JSON. Yeah, those things like I think if you go to RPC, any RPC, wallet RPC or any kind of RPC and any function, say get blockchain info.
Okay.
Yeah, RPC help manager also will do. Yeah, RPC help manager for get ZMQ notification. Yeah. So,
I don't know what this.
Yeah.
Okay. Should I go something in? What
Get blockchain info?
They're not given up.
Haven't given the curl here. Or you can see that by running Bitcoin D and doing Bitcoin CLI help, but yeah, get blockchain info help get blockchain info.
Right.
There. So that's the curl command. And you are basically sending that HTTP, whatever inside that curly bracket, it is basically an HTTP string with a method and some parameters. Content type, text plain, HTTP endpoint 8332. So basically you can send HTTP request to Bitcoin core RPC port and it will send you a reply if you give it the correct HTTP request. Bitcoin CLI is basically an helper app to do that instead of like writing all those big curl functions.
Do we need a user?
Yeah, you have to set username password in Bitcoin core conf, bitcoin.conf. I mean,
Right.
people can try that later on in there. It's kind of out of context for our place, but that's what an RPC is. Just an HTTP request server thing, like a web server. Nothing more than a web server. If you understand web server, you understand RPC.
That's really cool. Like I've always I've never noticed the curl thing. Like I mean I've seen it, but I've never looked into it.
Yeah. It's really cool. Like it's very simple, standard HTTP request response thing. Yeah, Fazal. Faisal, you are muted.
Oh, sorry. These two commands, can they be used interchangeably? The Bitcoin CLI get blockchain info and the one using curl?
Yeah, they're same thing. They will give you the same
Okay.
response.
Okay, yeah, got it. Thank you.
Yeah. You can write your own Python code to send curl command to Bitcoin Core RPC endpoint and get response that way also. You don't have to use Bitcoin CLI. So curl is like a basic library. It's a very old and popular library, and it's a way to send HTTP to stuffs out there in web. So it's used in almost everywhere, all throughout internet and stuffs.
And it's open source.
It's
Wow.
open source, yeah. It's maintained by one single guy actually. This Badger guy. He has been maintaining curl for what, last 20 years or something.
Damn.
Yeah, it's pretty old, as old as internet.
I mean, now we have better stuff like Postman and all, but still, like we share how to send HTTP requests with curl commands, and then we can import it with fancy UIs and stuff. But still, curl commands are used.
Yeah.
What is a better replacement for that, ML? What did you say?
So there's this Indian company called Postman, which is famous now, but there's open source
Postman.
alternatives. Yeah. So that has fancy UIs. You don't have to deal with the terminal.
Right.
But, yeah.
Is
Postman
Postman
is-
open source?
Postman
No.
was open source. I think now it's a company and people don't like it anymore.
So they
I don't
asked,
think it's open
like,
source, right?
does Postman use curl on the back?
I don't think so. No, curl is like a terminal app, right?
Yeah, it's a terminal thing. It's kind of like
Yeah.
not even a terminal. You can like use curl as an app in your programming language also, like in your Python code also and stuff. So there are like curl libraries in all languages.
No, but then that'll be something else, right? It's just an HTTP fetch.
Yeah, it's an HTTP fetch
yeah.
basically. Yeah.
I didn't know they were Indian.
Oh yeah, nice.
A bit startup.
Yeah, I think we missed a question. So Kevin asked, what does is fully valid check do?
Yeah, we missed a question. Yeah, what does this fully valid check do? That's a good question. Is fully valid? Yeah, so that's what it does. So it basically checks whether like the pub key is of the correct types and serializes properly, and then it uses the ACCP 256K1 API to check whether the public key is on the curve. I guess that's the only two checks you need to do. Valid format and in the valid curve.
Yeah, that was already there. Yeah.
Yeah.
So commit description, he mentioned three things. One is whether it's cryptographically valid. That's done by the
is fully valid check. Yeah.
Other things like if it's a hex string, if it's has valid length, all those things are done outside.
Right. Yep. Okay, we are almost towards our end. So what else we need to check here to review it
Wow.
fully.
Okay, always whenever there are like a very good way to contribute is, I think the stack has already implemented it. Like whenever there are new stuff like this, you always have to add test coverage for it. So I think that's what this raw transactions.py is. Like he's basically
sending wrong data and checking the correct messages, error messages are thrown in correct places.
Yeah. So right now in our test, we'll want these 3 different kind of error messages to be thrown. Right now he is must be a hex string, must have length. So we'll also need that cryptographically invalid thing. Must be cryptographically valid. So we need to add test coverage for this. But I think he added it in the last commit, like he mentioned it in his
right.
PR. So yeah, that's okay. And like you can also see more refactoring done here. Like because these checks are now moved into HexToPubKey, you can remove it out of other places. Like in create multisig, RPC helpman, if you look, there were all these stuff.
Right.
Like,
individual checks which were checking whether the key is of light length and other things. Now we just need to call HexToPubKey.
Yeah, we just need to call that.
Makes sense. So that's where the deduplication of the code came. So you don't have this repeated code all the places.
Yeah.
Makes sense. So can we look at the full change set of all the commits?
Yep.
Yep. And yeah, somebody was asking something.
So actually, I was saying if we have some extra time, can anyone please explain like how exactly are we? What is the test that framework that we are using to write Bitcoin tests? Because the tests are written in Python and the code is in C++. So like I went through it and I found that there is some implementation of Bitcoin and I guess there is some test framework made. So if anyone can briefly touch on that topic.
Okay, so quick brief on that. So Bitcoin has a functional test framework called inside test functional, where if you go into that example.py, there is a example Python file where how to write Python tests. And we did covered it in a video of inside in our Bitshala YouTube channel in the review club. If you go to very early, the first 2 videos, the second video talks about the test framework and the functional testing framework. So the basic idea is in functional test, you want to test Bitcoin as an entire black box. So you want to test the Bitcoin node as a black box running. So in functional test, what you can do is like you can spawn various Bitcoin rect test node, like 3 Bitcoin rect test nodes connected among each other with a network topology, and then you can check whether the node holistically is behaving properly or not. And these checks are done using a Python code, and these Python codes are used inside test functional, and it's pretty easy to read. It's quite fun to play around also, and that's one of the first places where you should look for contributing into Bitcoin code. Instead of C++, you just have to write Python, and at the same time, just by writing Python in that test framework, you can do all sorts of things. Anything that you can imagine. You can create your own network topology, you can create your own reorg situations, you can create your invalid P2P messages and all those stuffs. So functional tests are basically used to assert behavioral changes of Bitcoin code, right? So this one is a behavioral change. So some RPCs got changed and now there are error messages for various different cases, and we want to check those behavior. And that cannot be checked in unit test. In unit test, you just check individual functions. So you want to check Bitcoin code as a whole. For that, you do a functional test. Does that answer the question?
Yep. I'll check the video out.
Right. Yep. That video and example.py will give you all the context you need on how to use the functional test framework. Then just look around some example. There are lots of functional test files out there. Just read through one file and you will understand what the test is trying to do and how to do various things. So here in this code, you can see like the self.node1 create raw transaction. So basically you are using the node to create a raw transaction, signing that raw transaction, decoding raw transaction, sending raw transaction into network, all sorts of things. Like the ultimate power user mode of using Bitcoin code is probably writing Python code in the functional test.
Makes sense.
And we also did a deep dive into the functional tests. You don't need to know all that. You just need to know how to write tests. But that I really like this exercise which we have linked here. So like a really easy test that everyone can write. And just
Right.
to get familiar with the
Strat, can you send this link to that our review club that we did here in the chat for people to? Not this one, the review club link. We had more context on that. Yeah. So we were talking about functional test over there, and a lot more details can be found in the video recording of that review club also. Okay. So last thing we want to check is like holistically check at what all the changes that happened in the full PR. So this is source RPC output script.cpp where they were using those checks individually. Now we don't need them anymore. So HexToPubKey for the win.
yeah.
Makes sense.
Yeah, we moved all those checks in. So we oh yeah, it just throws. So I mean, so if this fails, we'll just throw an error, right? Like it. So nothing. I'm confused whether anything will get pushed to pubkeys if an error is thrown.
I think if the error is thrown, nothing will be pushed.
Okay.
I'm hazy on error handling on C++, but my guess is that.
Yeah, I might check it after this call.
Mhm.
Okay. And then
that's the utility function that we checked. HexToPubKey got more elaborate now. Previously, it was just doing some basic checks. And every time it was saying invalid pubkey, it wasn't saying why the pubkey was invalid. Now, depending upon what condition failed, it checks, it throws error accordingly. So this is the main chunk of the heart of the PR. Then RPC addresses.cpp, there was some individual check for the keys. I think add multisig address. So that's an RPC call. So if you go into wallet RPC addresses.cpp, you will see all the Bitcoin CLI command that you write in terminal. You will see those command name as functions. So when you run that command, what happens? Those functions get executed. Right. So if you look into those functions, you can see what happens internally inside Bitcoin CLI or inside Bitcoin core node once the Bitcoin CLI throws that RPC call. Right. So addresses, this one is add multisig address, that also an RPC API. And so when you call Bitcoin CLI add multisig address, whatever is written inside this function, that gets executed. So previously there was some length check about the address that you are importing, and now it's just HexToPubKeys, right?
HexToPubKey, what is this?
So this is in RPC backup, import pubkey. So this is the backup.cpp where the backup related RPCs are handled. So there is a function called import pubkey where you import an individual pubkey into the Bitcoin Core wallet. So there was some checks, which is now HexToPubKey and done by there.
Yeah.
Same thing in some other function. This one is process import legacy. I don't know what that function does. but it seems like it processes and imports an legacy address. Same story, some checks, instead HexToPubKey. Then this one is RPC spend. It includes all the spend related RPCs. This function is called fund transaction. So fund a transaction takes some pub keys somehow. It's also good to understand, like to go and check and look into these functions individually and just understand the context around the code that is being changed. So at the same time you're reviewing the code and you are also like gaining extra context around various parts of Bitcoin code. So if you repeat this exercise over and over, that will give you a good enough context about various parts. So here you are checking this part. What you want to do is like go look into fund transaction and check what fund transaction RPC call actually does inside Bitcoin code. Right. So here also the same story, some individual error clubbed into HexToPubKey. And now we are going into functional test, RPC raw transaction.py. This is where it added raw transaction.py. So this functional test is about RPC. So this functional test tests the RPC calls and RPC call related to raw transactions, right? So I guess create raw transaction, decode raw transaction, send raw transactions, all these kind of things. And there it is like checking for some public keys and asserting some errors. And yeah, so first error is like public key is not of light length, and second one is like not a valid public key. Then wallet basic.py. This is also raising some errors. Must be a hex string, so it's not a hex string. Then too short public key. It's not 33 bytes, and then not on the curve pub key. So interesting. This is how he created a not on a curve pub key.
Just 0, 0.
Just zeros, yeah.
Yeah.
And then wallet fund raw transaction. So this is also where some pub key error was raised, and but I guess like these pub key errors are now being repeated in multiple functional tests, right? But he just like kept the error situation same. So if there was some error condition before, he just modified the error condition with better handling of messages.
Yeah. Which APIs? Oh, fund raw transaction. Oh, the
Fund raw
stuff we,
transaction, yeah.
yeah. We should also check if we really did do this change everywhere.
Yeah, that's another thing to change. So we want to make sure like all the places where is HexToPubKey could be used are used.
It's just a lot of block stuff, but that's not relevant to us.
Yeah, I think it will require a more manual check than kind of like we can check for whether there was any other pubkey assertion elsewhere. Or we can check for like throw -5 error wherever there was a -5 error. We should be able to check.
-5 is this RPC invalid.
Okay.
But apparently that's thrown in a lot of places, like even address or key. So even for addresses and private keys. I don't think they're obvious. Yeah, all this stuff are anyways here now. Looks good.
Yep. These are all the individual exercises that reviewers can do on their own. Then a helpful review comment is whether all the places where it should be covered is covered or not. Whether you can add any more edge cases. I think for this one, it's not. Running the unit test, running the functional test, checking everything is running locally well inside your system. That's just the basic operation. And then if you have any code suggestions or doc suggestions, then you can comment about that. These are usually all the helpful review comments.
Yeah. And if you're contributing for the first time or like pretty new contributor, like you can tell them all, like you tested these stuff, like the things Raj mentioned.
Right. Yeah.
So people will be.
That's also like a valid thing to report. Like, hey, these are the tests I did, all good, or this one was wrong, or this is where I was getting some unexpected results and all these things.
Yeah.
Cool. We are at our 1 hour mark, and any more further questions? Last round of question.
No questions from mine, but I just like to congratulate Chatusva for her choice of peer. I think this was a very good choice for her to review in our Vichala session, because most of us like have issued these RPC commands in the sessions that we've covered before, whether it's LBTCL or programming Bitcoin. So like we're familiar with public keys and the format and what errors could occur. So like at least I can speak about myself. I was really able to relate to what the PR is trying to achieve and what error checks it's performing. So like my feedback is it was a great choice.
Awesome, for sure. Yes.
It's actually like I got the PR because it was put in the priority board. Like there's something called projects board on GitHub, and these are like the PRs which are high priority for review, and it is listed in the blockers. So
Okay.
it's a pretty good PR to review.
Yeah. It's a simple one. It's a good one. It's also like a good place for new contributors to start reviewing and commenting. I mean, this PR is waiting for a long time. It can use some reviews and concept ACKs and test TACKs and stuffs.
Yeah, it's great you can understand this too. Even though it's pretty easy, it's still on the blockers list in the high priority.
Right. So we are really helping Bitcoin Core moving forward.
Yeah. That's
Do
amazing.
post your review, guys. Okay, cool.
That won't be marked spam, na?
Sorry?
I'm asking that won't be marked spam, na? Because like
nobody worries about spam when it comes to review in Bitcoin Core. The more you spam, the better it is.
No.
Because recently there has been some activities around the Express.js.
I mean, like spam is like something where like you go like all those meaningless discussions like that doesn't conclude. But putting like a basic review, like just a concept and tested ACKs is not spam. Even like posting questions in review comment is not spam.
Tell them what you tested.
Yeah.
That is not spam.
Okay, sure. Thanks a lot, Raj, and just try to say.
Cool. Great session today. Lot many people joining in. We are growing in our club participants. So great stuffs. Okay, so this is a wrap for this week. Thanks, Strat, for the PR and helping us go through it. Week after next, Thursday, same time, we will come back with another PR review session. Till then, catch you guys around and happy learning. Bye-bye.
Bye.